Good morning, all of you. So, today we are going to begin our new chapter, that is chapter 6, Lines and Angles. I hope you all know what are lines and angles. So, in this chapter, we will be studying some axioms based on the angles formed between lines and their related applications, which will be very useful. So, let's begin. So let us study some basic terms and definitions. A part or portion of a line with two endpoints is called a line segment. Okay, a part or portion of a line with two endpoints is called a line segment. So a line segment will be having two endpoints. We can name it as A, B. Okay. Now, what is a ray? A part of a line with one endpoint is called a ray. So, for a ray, there will be only one endpoint and the other end will be extending to infinity. Note that the line segment AB is denoted by AB and its length is denoted by AB. So, line segment AB is denoted by AB with a bar above that and its length is usually denoted by AB. Now the ray AB is denoted by AB with a narrow mark above that and a line is denoted by AB with double headed arrow mark above that. So these are the common notations for notating line segment, a ray and a line. Now we will not use these symbols and will denote the line segment AB, ray AB, length AB and line AB by the same symbol. Okay, usually in this text we follow the same symbol for all these. Now, if three or more points lie on the same line, then they are called collinear points and otherwise they are called non-collinear points. Okay, that is if three or more points lie on the same line. Okay, when we can draw a line passing through all these points, then we can say that all these 3 points are collinear, and otherwise, that is, if we cannot draw a line passing through all these points, then we can say that these points are non-collinear points. An angle is formed when two rays originate from the same endpoint. Okay, so from the same endpoint, if two rays originate from the same endpoint, then we can say that an angle is formed between them. The rays making an angle are called the arms of the angle. Okay, the rays making an angle are called the arms of the angle, and the endpoint is called the vertex of the angle. Okay, so that endpoint is called the vertex of the angle and the rays making an angle are called the arms of the angle. Okay, now you have studied different types of angles such as acute angle, right angle, obtuse angle, straight angle and reflex angle in earlier classes. So consider some examples. So for an acute angle, you will be having 0 degree less than x less than 90 degree. That is, an acute angle is between 0 degree and 90 degree. Next, the second figure denotes a right angle. Y is equal to 90 degree. Okay, right angle means 90 degree. The third figure represents an obtuse angle, that is the angle Z lies between 90 degree and 180 degree. Obtuse angle measures between 90 degree and 180 degree. Now the fourth figure that represents a straight angle S, that is equal to 180 degree. Straight angle means 180 degree. That is the first figure in the bottom. And the second figure in the bottom represents reflex angle, that is between 180 degree and 360 degree. Okay, angle T that lies between 180 degree and 360 degree. So acute angle measures between 0 degree and 90 degree. Right angle is equal to 90 degree. Obtuse angle is between 90 degree and 180 degree. Straight angle is 180 degree and reflex angle is 180 to 360 degree. Okay. So, an acute angle measures between 0 degree and 90 degree, whereas a right angle is exactly equal to 90 degree. An angle greater than 90 degree but less than 180 degree is called an obtuse angle. Also recall that a straight angle is equal to 180 degree. An angle which is greater than 180 degree but less than 360 degree is called a reflex angle. Further, two angles whose sum is 90 degree are called complementary angles, and two angles whose sum is 180 degree are called supplementary angles. So you have learned about acute angle, right angle, obtuse angle, straight angle, reflex angle, complementary angles and supplementary angles. Complementary angles means two angles whose sum is 90 degree. Okay, that is they complement each other. So their sum will be 90 degree. Similarly, supplementary angle means two angles whose sum is 180 degree. Okay. If the sum is 180 degree, then they are called supplementary angles, and if the sum is 90 degree, then they are called complementary angles. So, two angles are said to be adjacent if they have a common vertex, a common arm, and their non-common arms are on different sides of the common arm. Okay, two angles are adjacent if they have a common vertex and a common arm, and their non-common arms are on different sides of the common arm. For example, in the figure, you can see angle ABD and angle DBC are adjacent angles. Ray BD is their common arm and point B is their common vertex. Ray BA and ray BC are non-common arms. Okay, please check the figure. So that in that figure it is clearly given that angle ABD and angle DBC are adjacent angles because they have the common arm BD and common vertex B, and the other non-common arms lie on the different sides of the common arm. Moreover, when two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. Okay, when two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. That is obviously clear. Sum of these two adjacent angles will be the angle between the two non-common arms. So, here we can clearly write that angle ABC is equal to angle ABD plus angle DBC. Okay. Now you are going to study about linear pair of angles. So if the non-common arms BA and BC in the figure 6.2 form a line, then it will look like figure 6.3. So in this case, angle ABD and angle DBC are called linear pair of angles because these angles form a straight angle, okay, from a line. So you can define these angles as linear pair of angles. Okay, angle ABD and angle DBC are called a linear pair. They are a pair of angles, adjacent angles, and they are called a linear pair of angles because they together make a line ABC. They together make the line ABC or AC. Hence, they are called linear pair of angles. Now we are going to see vertically opposite angles. So you may also recall the vertically opposite angles formed when two lines, say AB and CD, intersect. Okay, so when two lines intersect, we can see that vertically opposite angles are formed. So in this figure, you can see that angle COB and angle AOD are vertically opposite angles. Similarly, angle AOC and angle BOD are vertically opposite angles. So I have marked them with a single angle mark and double line angle mark. Single line angle mark is angle AOD and angle COB, and double line angle mark is angle AOC and angle DOB. So they are pair of vertically opposite angles. So Now you draw two different lines PQ and RS on a paper, and you will see that you can draw them in two different ways as shown in figure 6.51 and 6.52. That is, you can draw these lines either in such a way that both these lines intersect or in such a way that both these lines never intersect. Okay, that is, either they are parallel or they are intersecting. So in the first case it is given as intersecting lines, and in the second case it is given as non-intersecting or parallel lines. So note that the length of the common perpendiculars at different points on these parallel lines is the same. This equal length is called the distance between two parallel lines. Okay, so in the second case you have drawn it as a pair of parallel lines, and in that the common perpendiculars at different points on these parallel lines will be the same. Wherever you are drawing the perpendicular distance, you can see that that will be same in case of parallel lines, and this equal length is called the distance between two parallel lines. Okay.